NEC Table 310.16 mandates the use of number 12 AWG copper conductors for branch circuits rated 20 amps. NEC Table 310.16b directs the ampacity of number 12 AWG copper conductors by 20% for continuous loads. Therefore, the derated ampacity of number 12 AWG copper conductors is 16 amps, which is calculated as 20 amps times 0.8. You have installed number 12 AWG copper conductors on 20 amp breakers. Your original design used 16 amp load for each home run, accounting for the 80% derating due to continuous load requirements. The question is whether it is safe to load each lighting circuit to 20 amps. Since number 12 AWG copper conductors are already derated by 20% for continuous loads, it is not possible to safely load them to 20 amps. The maximum allowable load for your number 12 AWG copper conductors is 16 amps, which is the derated ampacity. The use of 20 amp breakers on number 12 AWG copper conductors is a violation of NEC Table 310.16 and could result in overheating and a potential fire hazard. To ensure code compliance and safety, you cannot load your lighting circuits to 20 amps on number 12 AWG copper conductors with 20 amp breakers. If additional track surface is required, consider adding another home run with number 12 AWG copper conductors protected by a 15 amp breaker. Alternatively, replace the existing number 12 AWG copper conductors with number 10 AWG copper conductors, which have a derated ampacity of 20 amps, allowing for the desired load while remaining compliant with the electrical code. The key takeaway is understanding the ampacity of conductors and the impact of continuous loads on their allowable current carrying capacity. Ignoring these factors can lead to unsafe conditions and code violations. When designing electrical systems, it's essential to carefully calculate the load requirements and select conductors and overcurrent protection devices accordingly. Remember to consult the latest edition of the National Electrical Code and any local amendments to ensure compliance with all applicable regulations. Continuous loads are defined as loads where the maximum current is expected to continue for 3 hours or more. This definition impacts how conductors are sized, and overcurrent protection is selected because sustained high current flow generates heat within the conductors. The NEC requires that conductors be derated to account for this heating effect. The 80% rule, as it's commonly known, is a direct result of this derating requirement. Specifically, it means that the overcurrent protection device should be rated no higher than 125% of the continuous load, or conversely, the continuous load should not exceed 80% of the breaker's rating. This ensures that the conductors are not subjected to excessive heat buildup over extended periods. In the case of track lighting, it is highly probable that the lighting will be on for 3 hours or more, especially in a commercial art showroom. Therefore, track lighting systems are almost always treated as continuous loads. It is imperative to factor in this consideration when designing the branch circuits that feed track lighting. The selection of wire gauge and breaker size must reflect the continuous load requirements. The information available suggests that number 12 AWG copper conductors were initially installed, protected by 20 amp breakers, and the design accounted for 16 amp continuous load. This conformed to the 80% rule because 16 amps is 80% of 20 amps. However, the issue arises when there is a desire to increase the load beyond the 16 amp limit on these existing circuits. Increasing the load without upgrading the wiring or adjusting the breaker size would violate the NEC and create a potential safety hazard. The conductor ampacity is the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Table 310.16 provides ampacity ratings for various conductor sizes and insulation types, based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. This table is a fundamental reference for electrical designers and installers. The table provides ampacity values for conductors with different insulation temperature ratings, such as 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The temperature rating indicates the maximum temperature the conductor's insulation can withstand without degrading. In practical applications, the lowest temperature rating of any connected termination, conductor, or device dictates the conductor ampacity that can be used. For example, if a breaker is rated for 75 degrees Celsius terminations, then the ampacity of the conductor must be based on the 75 degrees Celsius column in NEC table 310.16, even if the conductor itself has a 90 degrees Celsius insulation rating. For number 12 AWG copper conductors, NEC table 310.16 typically shows an ampacity of 30 amps for 90 degrees Celsius insulation, 25 amps for 75 degrees Celsius insulation, and 20 amps for 60 degrees Celsius insulation. The specific ampacity to use depends on the temperature rating of the terminals and equipment to which the wire is connected. If the terminals are rated for only 60 degrees Celsius, the 20 amp value must be used. For 75 degrees Celsius rated terminals, the 25 amp value can be used. While the wire might be rated 90 degrees Celsius, the lower rated termination dictates the allowable ampacity. It is extremely important to select the correct ampacity value from NEC table 310.16 based on the temperature ratings of the connected equipment. Using an incorrect value can lead to undersized conductors, which can overheat and create a fire hazard. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. They are rated in amps, and their purpose is to interrupt the flow of current when it exceeds the device's rating. The NEC mandates that the overcurrent protection device be sized to protect the conductor based on its ampacity. Specifically, the overcurrent protection device should not exceed the conductor's ampacity rating. This is a critical safety requirement. If the overcurrent protection device is too large for the conductor can overheat before the breaker trips, potentially causing a fire. In this situation described, number 12 AWG copper conductors are protected by 20 amp breakers. This means the conductors are protected against currents exceeding 20 amps. However, because the lighting load is considered continuous, the maximum allowable continuous load in the circuit is only 16 amps, which is 80% of the breaker's rating. The existing setup, with a 16 amp load on a 20 amp breaker using number 12 AWG copper conductors, is code compliant, provided the terminals are rated for at least 60 degrees Celsius. If it's rated for 75 degrees Celsius, then the 20 amp is still compliant. The problem arises when the load is increased beyond 16 amps. If the load exceeds 16 amps and remains continuous, the number 12 AWG copper conductors will be overloaded, even though the 20 amp breaker hasn't tripped. This is because the conductors are only rated for 20 amps under normal conditions, and the continuous load dirting reduces the safe carrying capacity to 16 amps. In this situation where additional track surface is needed, one possible solution is to add another home run. A home run is a dedicated circuit that runs directly from the electrical panel to the lighting location. This provides a separate pathway for the additional current demand. The new home run can be wired with number 12 AWG copper conductors and protected by a 15 amp breaker. By using a 15 amp breaker, the maximum continuous load in the new circuit is limited to 12 amps. Which is 80% of 15 amps. This ensures that the conductors are not overloaded even with a continuous load. Alternatively, the new home run can also be wired with number 12 AWG copper conductors and protected by a 20 amp breaker, provided that the total continuous load in the new circuit does not exceed 16 amps. Another possible solution is to replace the existing number 12 AWG copper conductors with number 10 AWG copper conductors. Number 10 AWG copper conductors have a higher ampacity rating than number 12 AWG copper conductors. According to NEC table 310.16, number 10 AWG copper conductors with 75 degrees Celsius insulation are rated for 30 amps. With the continuous load dirting, the maximum allowable continuous load on a 20 amp breaker using number 10 AWG copper conductors is 20 amps, which is within the ampacity of the wire. This allows for a larger lighting load in the existing circuits without violating the NEC. However, it is important to verify that the terminals and the breakers and lighting fixtures are rated for at least 75 degrees Celsius, Otherwise, the 60 degrees Celsius ampacity must be used, which would require a larger gauge wire. When making any changes to the electrical system, it is crucial to follow all applicable NEC requirements and local codes. In addition, it is recommended to consult with a qualified electrician to ensure that the work is done safely and correctly. Ignoring these factors can lead to unsafe conditions and code violations. The key points to remember are: firstly, the ampacity of conductors must be sufficient to carry the expected load. Secondly, continuous loads require conductors to be rated to 80% of their ampacity or the breaker to be sized to 125% of the continuous load. Thirdly, overcurrent protection devices must be sized appropriately to protect conductors from overloads and short circuits. Fourthly, NEC Table 310.16 provides ampacity ratings for various conductor sizes and insulation types. Fifthly, all electrical work must comply with the NEC and local codes. Sixthly, consulting with a qualified electrician is recommended for any electrical work.